Okay, what we have is where you have to find the correct molecular formula. Well, what you have to do is you have to find an empirical formula before you can find the molecular formula. So, previous video, or one of the videos, had to do empirical formula. If you know how to do that, then you can go ahead and do the steps on this. So, again, we're going to go ahead and change these all into moles. All right? So this is pretty repetitious, like empirical. Go ahead and divide them all out. First thing is, remember, we just change these percent signs to grams. So real easy. We just say it's like a 100-gram sample. We can do that. Then we go ahead and divide everything out. So this is 200.59 grams of mercury. This is 35.45 grams of chlorine, to 1 mole of chlorine. And then this is 16 grams of oxygen to 1 mole of oxygen. Okay, so really quick, I just showed the work. I stopped it, paused it to do the work. We realize, common sense, these two will be the same number of moles. So Hg and Cl will have the same subscript. We know that oxygen is going to be more. So common sense says the first two, mercury, they're both going to be 1. Okay? So this is going to be 1 mole of mercury. This is going to be 1 mole. Even though it rounds a little bit, it's a little bit farther off, but really close yet. And then we take the 3.35. This should give us a whole number we're hoping. So when we divide that by 0.35196, we get an answer of 3. So our formula is going to be HgClO3. So on the test, a lot of times students think, hey, I've got the answer, that's it. But you have to compare this mass to the mass of the 568. So what you have to do is you have to take the 1 mercury, the 1 chlorine, and the 3 oxygens and add them all up. So that's what we're going to do. Take 200.59, we got one of those, plus 35.45. We have 3 oxygens, and that adds up to 48. We get an answer of 104. So that's going to be 104. Nope, I made a miscalculation. So I'm glad I caught myself. I was like, no, that doesn't make sense. It can't be 104 if mercury is 200.59. So do it again. Sometimes that happens. Just double check yourself. Say, hey, this doesn't make any sense. And if you do a problem and it's not coming out to where it has whole numbers and that, just go back and double check your work. And, hopefully you'll have time. You won't get too nervous of redoing it. And do it again, and then you'll get it. Okay, so redoing that, we get an answer of 284. So this is equal to 284. Question is, how many times does 284 go into 568? So we take 568 divided by 284. Oh boy, we get 2. So when that divides into your molar mass, you'll get a whole number of what you can multiply everything by. So this compound, running out of room, is Hg2Cl2O6. And that's the proper formula. So, if you would like, you can go ahead and do that problem. And then I'll just show you the final answer after you do it, and not go through and explain everything in super detail, okay, until the very end. So go ahead and do that problem. Okay, so finish this up real quick. I just did the work you realize that 3.33 and 3.33 will be the same number of moles. 3.33 into 6.64, you got to realize that's 2. So we'll just go ahead and show it. So it's 1 carbon, 2 hydrogens, 1 oxygen. So our formula is CH2O. So then when we add this all up, 1 carbon is 12 grams, plus 2 grams of hydrogen, plus 16 grams of oxygen. So that all up, we get 30. Now that 30 goes into 90 3 times. So our formula is 3 times as big. So our formula is going to be, so our empirical formula is CH2O. So that's going to be 3 times as big. So it's going to be C3H6O3. And that's our formula. Okay? If you want to do extra problems dealing with the molecular formula, I can give you a couple to do. And you'll have answers on them. So it'd be like problem 83 on page 219.